Welcome to solverfy.
So here for part A, the damped angular velocity is going to be equal to the square root of the spring constant divided by the mass minus b squared over 4m. And so this is going to be equal to the square root of 41 newtons per meter divided by the mass of 0.835 kilograms. And then this will be minus 0.662 Newton seconds per meter squared. And then this will be divided by 4 times the mass of 0.835 kilograms. And we find that the damped angular velocity will be equal to 6.996 radians per second. Now for part B, they want to find the fractional change. So the fractional change would be equal to the amplitude times e to the negative gamma t minus a, the amplitude, divided by a, the amplitude. And so this is going to be equal to e to the negative gamma capital T period minus 1. And then we can say that this is going to be equal to exp. Exp just is the exponential function. So whatever is in the parentheses is the power with a base of e. So this would be negative b over 2m times t, and then close parentheses minus 1. We can solve and say that this is going to be the exponential function of negative 0.662. And then this will be divided by 2 times 0.835 kilograms minus 1. And this is giving us negative 0.300. So that would be your answer for part B, the fractional change. And then for part C, they want us to find the position of position function as a position function with respect to time. And however, the initial position is 0.120 meters. So the general equation for the damped oscillator will be equal to A times exp of negative gamma times the period, rather times t, times sine of omega prime times t. And so for the first part, we have 0.120 meters equals a x exp, or the exponential function, of negative 0.662 times 1 second divided by 2 times the mass of 0.835 sine of 6.996 radians. And so this is basically x at t equals 1 second equals 0.120 meters. That's how we're setting this equation up. And solving for A is simply going to be equal to 0.273 meters. You would simply have to plug this into your TA 84, 85, or 89 and solve for A. You can use the solve function in order to isolate A. So A is going to be equal to 0.273 meters. Gamma is going to be equal to b over 2m, and this will be equal to 0.662 divided by 2 times 0.835, and this is giving us 0.396 per second. And so constructing the position versus time, rather position as a function of time, x would be equal to, say x would be equal to 0.273 meters times the exponential function of negative 0.396t, and then sine of 7t. So this would be the full equation. That is the end of the solution. Thank you for watching.